What's up? I'm back with another update video. So I made a lot of changes to the code and added some new things. So I think I'm going to start by just walking through each file line by line, and then I'm going to do a demo of where I'm at right now. So first off, as you can see from the imports, I refactored a lot of things. I split some of the stuff in HTTP utils out into this method handling and constants files. And I'm doing some wildcard imports to pull things in from that. Probably not the best way to do it, but I'm using all of the names in those files, so that's what I'm going with right now. All of this is the same. We can see here, mostly with changes, I'm just printing the information about the connection more cleanly. So I print incoming connection, the socket object, and then the address for that socket. We're still pulling in data the same way. You'll see this in the next file, but I refactored this HTTP line request or request line object to store the method, any sort of arguments that might have been passed if it's like a GET request, and the protocol that was sent from the client. And here, just like normal, we extract the headers from the request in the headers separately. And I'm printing the headers because I represent them as a dictionary of keys and values, which is kind of already like how they're represented regardless in the raw bytes of a HTTP request. And then for here, right now I support two methods. I support get and post, and I plan to add more, but you'll see those in action in a second. So let's hop over to here in HTTP utils. So I actually do not need this tuple type hint anymore because I decided to do it a different way. So this is the new HTTP request line class. So all it does is you create it with this constructor. You take in the raw line bytes. So for that line, which represents the HTTP request, we take in the raw bytes, and then I'm splitting it up into the method, any sort of arguments that you might have, and then the protocol. So we start by using regex to split on the empty character in bytes, and that gives us back these 3 bytes objects. And what I try to do first is map the method to a HTTP requests object, which if we look over here, this is just an enum class that I have for all of the HTTP request types. So we're taking the bytes representing that method, decoding it to a string, and then trying to see if it exists in the enum. And if it doesn't, we accept a value error. The second thing we get is the raw args. So if we're hitting like the endpoint data /5 for index 5 within the data, all of that information is going to be delineated by a /. And so what I'm doing is basically checking if there are no arguments, then curl will just send you a single / in that section of the request line. And so if that's the case, we have no arguments, and so I set it equal to none. Otherwise, what I'm interested in is really just extracting the last value in that sequence of like the endpoint relative file path. And for my purpose, that is going to be a single number, which is the index of the row in the database which we're trying to interact with. And so the way I'm getting that is I'm splitting by /, and then I'm taking the last one, which is going to be the index if we do, like for example, if we did like curl -x get http ://localhost port 8080 /data /3. As you can see here, when this gets sent as a GET request, it's going to say GET space this bit here, and then the HTTP protocol after that. So if we're regex splitting on the bytes version of a /, and we take the last index of that split, it's just going to give us 3, which is exactly what we want. But it's still a bytes object at the end of the day. So as we know, regex bytes returns a list of bytes. So we're just, or potentially a list of bytes. It might just be a single byte in this case, like what we're doing. But I'm casting that explicitly to an integer. And then finally, we set one more attribute of this class where I'm taking the protocol, which would show up with the GET request, and I'm just decoding it as a string. Scrolling down, this is the same. This is also pretty much the same, but there's the get diff here because I deleted a method whose area this method now occupies. And also, I decided once I've implemented all of the various HTTP request methods, I'm going to trigger which function gets called with a match like switch statement, which is what this is here. As you can see, I'm just returning none on all of these because I haven't implemented it yet, but once I've implemented more than just get and post, this is what I will use. Let's hop over to this file now. As you can see, I have a bunch of empty methods that I intend to implement, but right now we've got post and we've got get. Get is pretty simple, so I'll go with that first. So basically, what I'm doing is I'm treating the database that the client is able to interact with as just this CSV file. And so if we want to get a particular index of the CSV file, here's what we're going to do. We're going to open it up in read mode, and we're going to create a CSV reader, dictionary reader object for that file. And then we're going to iterate line by line in the reader and wait until we find the index we're looking for. Then we return a dictionary symbolizing that row. And so the dictionary is going to have the columns of the CSV as keys, and then the values at that particular row for those columns as the values in the dictionary. Next, we've got post. So I'm doing a couple things here. So I realized if it's an empty database, first off, that's not really ever going to happen. But as you can see here, right now we've got an empty database. And so to initialize it, the first thing we do, the second thing we do is we try to see if there already exists a header at the top of the CSV. But first, before that, we take in our JSON data, which is going to be coming in from the post request. It's going to be a string, and we're going to load it as a Python dictionary. Then we're going to open up the CSV. We're going to create a reader, and then which is a generator of lines, right? So we're going to try to find if there are any first line words by applying the next method to the iterator. If there aren't any first line words, we say that the header is not present. But if the header is present, then or if there are first line words rather, we use the CSV sniffer, which basically looks at a string representing the first line of the CSV and tries to detect if it is or is not a header. So that's what we're doing here. So I'm taking in all of the first line words because what's returned by this iterator is a list of it's a list of the column names basically. And so I'm joining them together into a string where they're delimited by commas. And then this string ends up being the input to this has header function. All of this is to get a Boolean variable set for this first line words. So basically, whether or not first line words exist, the value of that Boolean variable is going to decide whether or not we go ahead and create those first lines for the CSV header. So this is the writing part of the post request. We're opening up the same file in append mode, and we are going to write the JSON object, which we're representing as a dictionary, where the keys obviously are going to be the columns and the values are going to be the values sitting in those columns. So remember, we set this header present Boolean. If the header is not present, we're going to use this write header method, which is already a part of the dictionary writer object. And then regardless of what happens, we're going to write the contents of the row, which are the values in the dictionary currently. And all this will make more sense when I actually do an example and you see it in action. Finally, there is one more file. All of this stuff already existed, but basically I moved the enums into here, and I also moved this hard-coded CSV path for the database. And since I'm doing a wildcard import for now, I defined the all dunder variable to just take in the status code and the request enums, because in the main function, we never have any reason to look at the CSV path variable. So I hope that all makes sense. I'm going to start up the server and show you guys what I can do with it right now. So the server is running. I'm going to make some requests with curl, excuse me, and we're going to see how that information gets printed to the terminal and also how the database gets updated. So actually, if I want to be fancy, let's do this. So we've got the database side by side. We can see the stuff getting written to the terminal as we speak. So, okay, so let's start with a post request. So let's create the first row and the header as well. So let's do curl-x post http://localhost port 8080, and now let's do our JSON object. So let's say we have one key, which is the name, and one value, which is the age. All right, let's see how this goes. Okay, so first off, we can see incoming connection. Here's the socket info, the address, here's our headers, and now we can see the initial columns got written to this CSV and the values got written beneath them. Now, let's act like we're adding another entry. So let's say the name now is James and James is 42. See? We are now just appending rows on like you'd expect. Let's do one more just for fun. So let's do Simon, age 70. All right, so I think I've demonstrated to you that the post request is working. Let's do a GET request. It's not HTTPS. So this is what I was talking about. So let's look at the item at index 1 in our database. So if we start from here, it should be Matt, but actually I think the way the code is written, it's going to give us James, because when you're doing the when you're using the reader, where are we? Yeah, so this dictionary reader probably omits the header at the top, so this is going to be index 0, and so if my argument is index 1, it's actually going to return you the data on line 3, which is slightly confusing, but maybe I'll find a better way to standardize it by having a key column where the key is agnostic to the actual row on the database. Anyway, though, I'm expecting this is going to give us James. Yeah, that's what I figured for the reason that I just described. But yeah, so basically, as you can see, we are able to make GET and POST requests to our toy database, which is literally just a CSV file. But yeah, this is big progress. I know in the previous videos I was talking about what methods I wanted to support and what content types I wanted to support. I'm not entirely sure what methods I'm going to support yet. I think definitely delete, options, head. Some of these things make sense, but other ones may not make as much sense. Like I don't know if I need to support connect, but that's still up in the air. As far as the type of data which I'm going to accept, I think generally, just to restrict the scope of this project, I'm only going to accept JSON data. So as you can see here, we're getting in JSON data, and this is how we're going to be sending data to our server, the HTTP server, which is hosting this mock database. So all of my methods I'm going to set up to be able to handle JSON data from the HTTP request body. And obviously, if I wanted to, I could handle other things, but that's not really the point of this project. The point of this project is just to touch the surface of building an HTTP server, not implement something that can handle every possible edge case with the content type. But yeah, that's it for this video. I honestly think with the progress I've made today, I should be able to finish out this project tomorrow and put it online. But yeah, all these changes and stuff I will put on GitHub. So yeah, please let me know if you guys have any suggestions or any comments or any sort of criticisms. But yeah,